Hi, my name is Ricardo, and I'm your host of Math Matters, and today we're going to be discussing probability, and specifically the probability of weather forecasts, which we call the probability of precipitation. Now remember, probability means the likelihood of an event to occur, and if we're talking about the probability of precipitation, the probability of precipitation means how likely it is to precipitate. So the probability of precipitation is data, or a piece of data given by meteorologists indicating how likely it is that it's going to precipitate. So usually, one example would be like 70% chance of rain tomorrow. If someone says that on the Weather Channel, you know that it's more than likely to rain, and that influences your decision to, let's say, bring an umbrella to work. And that is purely based in mathematics. The hint is that it's called the probability of precipitation, so you know it has to do with math probability, but it turns out it has to do a lot with the collection of several pieces of data, several events over the history of an area in terms of the weather, and how those all relate to precipitation in a very complex algorithm that is usually done by a computer. But we can simplify that here, and I'm going to show an example of a real-life application of how these different events can combine in ways we already talked about to do with probability of several events and eventually probability of precipitation. So, the example I have here involves 3 events, and our final probability is going to be the probability of a snow day tomorrow. So let's say I, as a high school student, want to find the probability of a snow day tomorrow, and I'm going to simplify it to say that it's based in humidity, temperature, and air pressure, our 3 events A, B, and C. So again, remember, this is the likelihood of a snow day to occur, and I'm saying for tomorrow. But let's say the probability of a snow day is defined as when the humidity is greater than 70%. That's one measurement, right? And so humidity does relate to a snow day because when it's more humid, it's more likely that it's going to precipitate because there's more water vapor in the air, clouds will accumulate, it will precipitate. And this doesn't mean it's going to be snow, it doesn't mean it's going to be a snow day. However, it does have one environmental factor. Temperature. So let's say the temperature also has to do with a snow day. Temperature doesn't mean that it's going to precipitate, just temperature in general. If it's cold, the days that it will precipitate will be much more likely to snow because it's cold. And the colder it is, the more likely that snow will accumulate on the ground, therefore piling higher and higher and making it more difficult to go to school, therefore snow day. So let's say we're going to do temperature when it is, we're going to enumerate temperature when it is less than 30 degrees Fahrenheit. And finally, air pressure. Now this is very commonly used by meteorologists, but you don't necessarily have to know what air pressure is. Just know that a low air pressure is usually associated, or falling air pressure is usually associated with poorer weather and more likely to precipitate. And that's one indication of what's going to happen in the next 24 hours that meteorologists use. So I'll say if the air pressure is less than 1,000 millibars, which again, measurement used by meteorologists, and you don't necessarily have to know this. So if we have measurements from the whole month of January in the past 5 years, that means for the 31 days in January, for the past 5 years, we have measured all of these values, and we have found out when the humidity is greater than 70, when the temperature is less than 30, and when the air pressure is less than 1,000. So, overall, how many days are there, and how many events have occurred overall? So, the bottom of our probability is going to be 31 times 5, which is 185. Because this is the total amount of times that any of these events could have occurred, because that's how many days we counted. So each of these A, B, and C are going to be fractions, with the denominators of each of them being 185. So let's say in the past 185 January days, the past 5 years in January, there have been 100 days of humidity greater than 70%. And yes, I'm making it up for the purpose of this example, but it's a reasonable amount, let's say. It's been a very humid past 5 years. The temperature, however, has been 180 out of 185 days. let's say we're in a colder climate and January is typically less than 30 degrees Fahrenheit, and air pressure is less than 1,000 millibars. That, however, has only happened about 30 times in the past 5 years. So, with all these different probabilities, we can calculate the probability of snow and the probability of snow day. In order to calculate the probability of snow such that a snow day occurs, or the probability of a snow day, we have to recognize that we're using these three events. So in this example, we're simplifying the probability of a snow day to be when all these three things occur. So when the humidity is greater than 70%, when the temperature is less than 30 degrees Fahrenheit, and when the air pressure is less than 1,000 millibars, snow day. That's guaranteed. So the probability of this happening on any given day of January, let's say tomorrow, as my example stated earlier, is the probability of A and B and C. So all of these have to happen. So the probability should be very limited. And if you watched the earlier video, you know about probability. The probability of A and B and C, the probability of three events happening, is the probability of A times the probability of B times the probability of C. So all these probabilities multiplied together, or the product of their probabilities. That's the result of a multiplication. Now here, all I did was copy down these probabilities from the data I already collected, and I have 100 over 185 times 180 over 185 times 30 over 185. Now, we're going to calculate the probability of snow day. So you pull out your handy back pocket calculator, and the probability is the multiplication of these three fractions. And the multiplication of a fraction is the top times the top over the bottom times the bottom. So all three should be all three tops, all three numerators, times all three bottoms, all three denominators. So, first, the tops. 180 times 100 times 30, or 100 times 180 times 30, is 540,000. That is the top. So already you know we're dealing with bigger numbers, much larger than simply a die. And these numbers become increasingly complex as the problem becomes complex. Because remember, this is a simplified version of this problem. Now the bottom, the denominators, all multiplied by each other. 185 times 185 times 185 is 6,331,000. Give yourself time to write it. 6,331,625. Okay. Now, this is the probability. Congrats, we finished our problem, right? However, this number right here doesn't make a lot of sense. It's not very useful to us, and it's not very useful to the public either. So this is why it's usually portrayed as a percent. So how do we get this to percent? Well, right now it's a fraction. We do the division. 540,000 divided by 6,331,625 is about 0.0853. Once we have this probability in form of a decimal, we can multiply by 100% to get the percentage form, right? So, 0.0853 times 100% gives us, let's write it over here, the probability of a snow day. Probability of a snow day equals 8.53%. Just because 0.0853 times 100 is 8.53%, the probability of a snow day as we calculated it is 8.53%. And there we are, the solution to our problem. Now what can we do with this probability? Well, with this probability we have a great estimation of how many snow days there should be in January, right? Because this tells us the snow days, or the predicted snow day of any day in January. Okay? If you knew the humidity and you knew the temperature and you knew the air pressure in general, if you knew all those things on a day and you knew this was the definition of a snow day, if these criteria were met, you would know there's a snow day for sure in this example. However, if you're just a common citizen sitting at home, like I would be, all I would have is this data. And I have these three pieces of data, and I can calculate how probable it is that there's a snow day. Now, with this, we know that there's 8.53% there's a snow day on any given day. Well, knowing that there's 31 days in January, why don't we just take this percentage multiply by 31, and we have a percentage. Again, remember it's divided by 100, so we have the decimal, in fact, 0.853 times 31 days, and we get about 2.6 days. So that means on average we have anywhere from 2 to 3 days that are snow days in this area in the month of January, and that's a nice approximation. Hi guys, thank you so much for watching my video. It really does mean a lot. And if you enjoyed this one, I encourage you to watch the next video in my series. And hey, if you're done with the series, there's always more mathematics to learn. Because remember, math matters.